Hello, everybody. Great. So thanks for joining. We're gonna go ahead and get started. Great. So yeah, feel free if you guys want to throw in some chat, some questions, comments, concerns. We got a lot I want to dive into today, so we're real excited to get started with this. So I'm going to go ahead and share my screen. Once again, if you guys have any questions, feel free to chat in the chat box or, offer any comments or suggestions. So just introduce myself. My name is Rusty Nye. I am from UBTECH Robotics, and I'm kicking off the start of an AI webinar series. So we're going to introduce how to teach AI in the classroom. Through the lens of our AI curriculum. So great. So first, to introduce you guys to UBTECH. If you're not familiar with UBTECH, UBTECH is a global leader in robotics and AI. So we develop intelligent robots for the workplace, for the home, and also for the classroom. We're currently working on a robust AI curriculum to introduce AI concepts to the K-12 classroom. So we're building our curriculum focused around AI for K-12's 5 big ideas. So through the next 5 weeks, we're going to introduce each one of these big ideas and give you tools to be able to bring these into the classroom and make them really applicable and accessible to students of a variety of ages. So for today, we're going to kind of just jump in and we're going to focus on the first big idea, which is perception. Great. So you all might be kind of like Tim here. So Tim, is a parent and educator, and he's looking for ways to teach AI. So AI is a huge field. There's a lot that you can touch on. So, kind of where do you start? So what we're going to do is we're going to start right at the beginning. So how do computers perceive the world? So that's the big question that we're going to dive in and answer today. So in order to first answer that question, we have to first compare to how do humans perceive the world? And that is through a set of sensors. So our sensors, as we can see, enable us to smell, to see, to hear, taste, and to touch. So we have 5 main senses. So computers and robotics have similarities and also differences in how they're able to perceive the world. So this is actually Yanshi. This is one of our humanoid classroom robots. And as you can see, Yanshi is able to perceive the world, to sense the world in ways that are very similar to Tim, but also ways that are very dissimilar. So where we have sensors, for example, like our eyes, Yanshi has a camera. This enables him to perceive, to sense the world, to see things, if you will. So the first layer that we want to touch on, is to note some of these similarities. What are the same, and then what are some of the differences and limitations between these different types of sensors? So where Tim, is able to taste something, that's a difference that Yanshi may not be able to, actually taste and gather that type of information, for example. So kind of expanding on this idea of sensors, once we have identified, looked at these differences in sensing abilities, the next layer to that is really perceiving. So it's pretty innate with humans in that we're able to see a tree and we know that's a tree. That's something that we have learned, through our experiences, and we're able to identify. But this is something in terms of robotics and computers that they are not actually able to do this innately. This is something we have to tell them to do. So if you'll see, Yanshi is able to see a person, but does Yanshi know that's Tim? Well, this is kind of where this idea of perceiving can really develop, and that we can tell Yanxi that he's able to perceive something as, something. So we can start writing these algorithms, and we can say that if Yanxi recognizes Tim, Yanxi can say hi, for example. This kind of elaborates into this big concept that we want to try to wrap around, that there's this three-level step. One, computers sense the world, then they perceive the world, and from there they will act and perform some sort of task. So great, I know that's, kind of a lot to take in, and how do we make that connection? How does this actually work? Without trying to dive too deeply into this, a very simplified answer here would be an algorithm. So to kind of explain this algorithm and put this in digestible terms, we can say that Yanxi first senses the environment. This would be known as the input data that's going into the computer, into the system. And from there, he'll make sense of that input data. And finally, he will act, so that he'll actually do something based on this, he'll actually perform an output response to what he has perceived. So this is a very simplified version of an AI algorithm, and we're really going to dive deeply into this hidden layer in the coming weeks. So this is something that we'll really expand on. You'll see this a lot when we're talking about AI, this hidden layer. This is what AI actually enables computers to do very well. And that is this perceiving, this perception idea. So we can represent this thought as a simple algorithm, in that if Yanxi sees X, Yanxi can perform a Y, for example. Great, so I know I see some questions coming through. If you guys want to direct questions directly into the chat box, that'd be great. We have some UBTECH experts on the line that can help you answer some of the comments or concerns. So great. So in terms of making this real, especially for students, how can we fold in, how can we give examples of this simplified algorithm really working in the real world? And a very a good example that we like to highlight is self-driving cars. So self-driving cars are actually performing this exact formula, if you will. And what they're doing is they're basically sensing the environment through multiple sensors all over the car. They're perceiving the environment, and then they're taking the action. So the action here is, something that means they're either hitting a car, hitting a person, or not. So it's a very important action. So, maybe we don't have self-driving cars ourselves. I personally do not. So what are some other examples that we can bring into the classroom that are very easy to understand? Something I really like to highlight is the app Shazam. Shazam is a sound identifying app. So this basically, what it utilizes is sound recognition to identify and make sense of a song. So you can represent this by the same algorithm, in that if Shazam recognizes a song that meets this parameters, it can label that song and thus identifying what song that is. Another example would be facial recognition within your smartphones. So certain smartphones, iPhones, are able to unlock the phone if they recognize someone's face. So this is also an example of that same algorithm. So if the camera on the phone is able to recognize, you know, Tim, for example, then it can perform the action of unlocking the phone. Great. So, excellent. So let me continue with the presentation. So great. So what are some examples? We might want to bring in some examples into the classroom. So I'm going to walk you guys through some different activities that I think are really fun to do with students. These are free online resources that you guys can have access to. The first one would be working through an emotion detector. So you'll see the URL is on the screen. You guys will have access to this after the webinar concludes. Feel free, you can, you know, play with this, tailor it to your classroom, to your students, you know, or at home. So first, let's go ahead and start so you guys can see me. Hello, everybody. So what this is going to do is utilizing the camera function on my computer, and it is generally trying to recognize the type of emotion that I'm expressing on my face. So it's doing this in real time. So it says, you know, if the computer recognizes a facial expression that it knows or has been told that is sad, it will label that with the label of sad or happy, vice versa. So this is a fun one you can do. It's very simple. It works in real time. And it's something you can start, you know, you can play with and, you know, play at home with your students. So great. So I know that's a pretty fun, simple activity demo you can do. But if we want to expand and really visualize and play with this idea of a computer perceiving something and making sense of it, this is a really fun demo that I like to do with students that is from Google. So it's currently hosted on Google Experiments. And have you guys seen this one before? This is kind of a classic one, but I do recommend, you know, turning up your audio all the way, and we'll go ahead and play with the Giorgio cam.
Ready to rock image recognition with me. Take a picture and it'll tell you what I see. Snap a photo. Here we go. I'm on it. All right. Cat's finger on my screen. Read. I think toy is what it seems. See. Okay, what else? Yeah. I'm on it. Looks like green to me. I'm seeing dinosaur, probably. Turn it up. Oh, all right. I'm on it. All right. Cat's hand on my screen. I think sporting goods is what it seems. See. Whoa. This is crazy. Yeah. All right. Looks like banana to me. I'm seeing peel, probably. One more time. Last one. Here we go. Go. All right. Is that pink or not? No. Got planted in this spot. Ah, that was awesome. I am shutting down.
Okay, what do you guys think? Is that a fun demo that you could do with students? I like to think that one's pretty fun. So great, as you can see, so this is a great example of representing that perception, or I guess I should start with sensing, perceiving, and then taking an action. And so It's applying that labeling, that action to its song, if you will. And if you saw, it wasn't necessarily completely confident with all of its suggestions. I thought there were some funnier ones, but this is an example of it mislabeling, having different information within the system. So these are just examples, really quick examples you can bring into the classroom that you can highlight with students. So if you will, those are all demos. We would like to also suggest different projects that you can build with students. So, how can you apply the same ideas to projects you might be building with students in the classroom or at home? So for this, we want to highlight our particular product, our software product, UCode. So UCode is available on our website. You can download it, you can install it on PCs and Mac as well. This is a software environment that enables students to actually utilize real-time AI blocks and build in a virtual environment as well as an uploading environment. So what I'm going to do here is we have 4 different levels and 4 different ways to connect and build with AI elements in real time. And students are able to build this in a virtual environment on their desktop, or they're also able to upload it to a robot that they build as well. So for this example, we're going to build a quick program that's able to utilize a body separation algorithm. So what this is this is a body pics data set that is hosted on TensorFlow. And so what this is able to do is actually perform real-time body separation. So what this will do is it will actually separate an image from the background. So I will And able to do this, we're going to build a very simple code that is also going to mimic this idea of AI algorithms that we're playing with. So what we can do is, and you'll see this is very similar to Scratch, if you will. It does enable you to code in a virtual environment. So very similar to, as you can see here. And what we'll do is we'll still mimic that same idea. So, and what I mean by that is the algorithm. So we're going to say that when the computer is able to sense the key being pressed, the spacebar, it is going to act by separating the image on the screen, myself, from the background. So let's see if that works. And as you can see, it is performing it in real time. So it will move with me. It'll be a little slow because I think I have a lot of windows open. Great. So I can continue building that out as well. So I can control it if I want to. Let's say I want to turn it off and on. Let's do a T for Tim. What do you say? Let's stop and start it. Oh, whoops. So as you can see, I didn't say turn off. I was expressing that, but I didn't acknowledge that. So there you go. So look, I was able to write this very simple code that basically mimics that idea of perceiving, acknowledging, or I guess sensing. The sensing here would be the touch. Then it's able to perceive, and that's what it's doing there is this block here, which is able to perceive myself and then separate that in acting, in that it's separating myself from the background. Cool. So that's a very simple code. And so what you guys can do from there, I'm not actually going to demonstrate this necessarily, but I have been playing with this robot here. This is something I built. So this is kind of just a fancy one. You see we have multiple sensors that we were able to, or I was able to build on this. There's a touch sensor here that I basically replace this block, the key. I can input that there, and then I can basically perform the same AI algorithm, if you will, the body picks, but also upload it externally to a robot. Great. Excellent. So I know that's a lot to cover. That was really quick, but there's a lot of fun you can do with it. So I want to do a quick wrap up, a little bit of a review, talk about what we're diving into. So the first real element that we really want to touch on when we're talking about perception is this idea that computers are able to sense the environment, and they do that by using sensors. So we can identify, we can look at these sensors by comparing them and contrasting them to our own sensors, that being our 5 senses as well. From there, you can expand on the idea of sensing the environment to perceiving the environment. And the main progression that we really like to focus on here is this element of first you sense, then you perceive or make sense of what you are sensing, and then you act. You perform some sort of action based on what you perceived. So this very simple 3-step progression is what leads computers to be able to interact with the world. So computers, robotics, etc. And once again, over the next few weeks, we'll really highlight this perceive concept within this progression, because this is where AI is really impacting computers and able to perceive and act in many different capacities. The simple explanation of how this works is by utilizing and focusing on AI algorithms. So we represent this by if a computer, if Yanchi sees something, if Yanchi is able to sense something, then he can do something else. So if Yanchi sees X, why not do Y? We also like to highlight that there are a lot of examples in real life that we come in contact with every day that really represent this idea of sensing, perceiving, and acting. So we can really look at this in terms of computer vision, sound recognition, image recognition. So I gave you guys 3 different examples that you can bring into your classroom or at home to help highlight these concepts. A lot of these examples that you can see in real life are really easy to do. They're really fun, and they really help highlight these concepts that we're trying to elaborate on. And lastly, you guys can also utilize these ideas to build some really cool projects. So you can build these ideas into your robots. You can build them into different computer programs that you're working with at home, and you could have a lot of fun with them. So thanks, Tim. Yeah, I know that was fun. I do wish we had a little bit longer, because I would love to highlight, dive more deeply into that, but that's what we're going to do moving into next week. So This was intended to be a quick demonstration, quick intro to some of these big ideas that we're building in to our AI curriculum. Once again, we're touching on just this one idea of perception. We're going to build and really dive more deeply into how AI is really working, in the weeks to come. So, you guys feel free to visit our website, ubtecheducation.com /home learning, or I guess /. We'll be hosting this webinar recording as well as the deck on there. And we look forward to hanging out with you guys next week for the webinar excuse me, number 2, we'll really dive into that hidden layer and talk about how computers are actually, forming models and representing and understanding their surroundings. So thanks again, everyone. Really excited to kick off this series, and look forward to seeing everyone back here next week.